ISC2 is proud to announce the winners of our Chapter Recognition Awards. For North America, the Northern Virginia Chapter. For Asia Pacific, Chennai, India Chapter. For EMEA, Nigeria Chapter. For Latin America, the Peru Chapter. Congratulations to all of our winners. Thank you for attending ISC2 Security Congress 2020. Before we get started, we have a few housekeeping items to note. Please know that at the end of this session, we will ask you to rate the session, and we look forward to hearing your feedback. If you experience any technical problems during the presentation, please refresh your browser. ISC2 members, CPEs for attending Security Congress will be applied to your account 30 days after the event. Please make sure you view at least 45 minutes of the session in order to earn the CPE. And now, here is your presentation.
Hello, my name is Ben Tom Have. I am a cloud security architect in my day job and also do some general security architecture consulting and strategy consulting on the side. Welcome to my talk today, 7 Layers of Container Insecurity. Before we begin, a quick disclaimer. As I mentioned, I do in fact have a day job. I am not here representing my day job in any capacity whatsoever, and so the views expressed in this presentation are those of myself and not of my employer. If we were all together in a room today, as we all very much wish we were, I'm sure, the first question I would really want to discuss with you is, where are you on your containers journey today? This is, in fact, a very important question because we're not all in the same place, not even close. Some of our organizations are dabbling with containers. Some of our organizations are very advanced and have full microservice architectures deployed on containerized environments. The reason this question is important is because there's a massive ecosystem in play today. Whether you're using Docker for containers or Open Container Initiative generic containers, whether you're deploying in Azure, AWS, Google, or even abroad in places like Tencent or Alibaba, there are considerable number of variables that come into play, not only around platforms, but around tools and technologies, as well as also talking about where we are in our DevOps journey and how we are able to support microservices at scale within our organizations. And oh, by the way, if you might have noticed, I've also left a word out thus far in this conversation. That word is security. So not only do we have all of the technical challenges of how do we do microservices and containerized deployments, but then how do we even go to the extent of securing all of this? One might say that the challenge has rather exploded over the last few years in particular. And this really has come to a head in the last couple of years especially, and we have even started to see growth beyond containers for microservices into serverless. And we aren't going to really touch on serverless per se. The focus here is container, but it is important to bear in mind that many of the challenges that we see with container security or container insecurity, as the case may be, really does also extend beyond that architecture to all microservices architectures. So let's start and talk about 7 layers of container insecurity. The starting point, really, when we start talking about securing our containerized environments, has to start from the inside, and that means secure coding and within the application itself. Developer education, training, and awareness is a very important part of this process and this conversation. We have to have very smart conversations with our development teams or engineering teams about how they plan to make use of containerized technologies, how they plan to architect for microservices, and how they plan to deploy and support things going forward. One of the key starting points in the conversation is to make sure that developers understand that containers are not simply a virtual machine in the traditional sense. Yes, sure, a container really does run very similar to a VM in many ways, but there are a lot of distinct differences in a container and how we manage them at scale that simply do not align. For example, how you scale things up, how you size containers, so on and so forth, don't actually have a good one-to-one comparison. Similarly, it's important that we design and architect and very explicitly take time to think about our architecture and our security practices from a secure coding perspective. Everything we deploy is increasingly being pushed out closer and closer to the edge with fewer layers in between. Therefore, just as we talk about zero trust and identity as the perimeter, in many cases, our applications are truly the perimeter as well. It's also very important that we leverage lean and test-driven development within our organizations. That helps drive a lot of maturity in development practices as well as in operational and security practices to allow us to address concerns proactively rather than allowing technical debt to accrue and build over time. We also need to talk about tool chains and how we integrate our security practices within those tool chains, beginning with the IDE. It is not acceptable to backload all of our security tooling and rely on that to catch everything after the fact. In an organization that's doing DevOps or at least agile development methods, oftentimes our feedback will come far too late in the process if we wait until the end. And so it's very important that we get things pulled as far to the left or up front as possible. And lastly, we really do need to have a very explicit conversation about how we are moving to cloud native architectures and the need for microsegmentation, such as to reduce blast radius, as AWS likes to phrase it, as well as how do we optimize our environments. Too much sprawl is too easy to occur and continue out of control over time. And so it's very important that we have these conversations up front. Organizations that don't take the time to have these strategic conversations that really apply at the secure coding level or even before that at the design and architecture level will have challenges over time in terms of supportability, operational support of deployment models, and so on and so forth. So now that you've got secure code and you've got your development teams on board, let's talk about how we actually get into the details of application security in the second layer. Writing code is one thing, but it still needs to go through a pipeline of some sort in order to get into production. Hopefully in your environment, you're not seeing developers simply write code, throw it in production, and boom, you're done with no checks along the way. You really need to implement testing as much as possible at every possible layer. That typically will be a blend of contemporary and traditional testing approaches, such as static application security testing and dynamic application security testing. Also making use of software composition analysis to knock out the low-hanging fruit. For example, we don't want development teams deploying on old base images or with old libraries that have numerous known vulnerabilities in them. We want to keep people as close to current and fresh as possible. That also ties into having conversations around the operating system and base image that's being packaged into your containers. We want to make sure that, again, we're not allowing developers to work on outdated base images, but in fact working from and actively testing from a vulnerability management perspective, the base images that they're developing against. We also need to make sure that the underlying management environment, such as Kubernetes, as well as the containers themselves, are being actively tested, including scanning for configuration checks, as well as looking for bad practices, such as open root access on system ports, as well as embedding of keys and things of that manner within our environments. As part of this, we really want to strive to automate as much as humanly possible within the pipeline. Again, let me say that one more time. We must strive to automate as much as possible within the pipeline. Now, for security professionals and security tooling, this can be extremely difficult to do. We are starting to see integration within CI/CD pipelines, native integration of tooling. One looks at some of the advancements that GitHub has deployed, such as Dependabot, as well as GitLab, actively integrating numerous security capabilities directly within their tooling and infrastructure. That is starting to provide a somewhat easier footing for us to get in there. But if we're trying to integrate legacy tools, that can oftentimes be very challenging. And really, the bottom line here is to think about continuous operation with optimal integrations. So take the time to understand how are engineering or development teams working? How do they do their jobs? What do their sprint cycles look like? What is a normal duration for a given development cycle? And how can we work to provide them with timely feedback in a DevOps sense, that we're talking about shortening feedback loops, allowing them to get that feedback in a timely manner so that they can make changes right away when they're working on code, rather than after the fact when it's more difficult to go back and do rework. And by the way, this also, again, puts an emphasis on having those design and architecture conversations as well to make sure that business logic flaws do not make it into these designs as well when it becomes much harder to support. This also contributes to a conversation that we need to have around maintainability of code over time, and maintainability of the containerized environments. And so we'll talk about that a little bit more with layer number 3. So layer number 3 is an interesting one because it really starts getting us away from the true developer conversation and more into a traditional infrastructure type conversation. However, as with most things these days, we now are talking about infrastructure as code and not so much about just traditionally deploying an operating system or a VM and then going and post-loading all of the application components. Within containers, you are in fact baking everything in together within the tool chain and then deploying the entire built application on the built base image into your hosting environment. In order to optimize kind of the basic security there within your container, it really does pay dividends to use a purpose-built lean operating system as the basis for your environment. Now, whether that's using something like BottleRocket from Amazon or CoreOS or Linux Kit from Docker, there are a few options for you out there. Even using things like Alpine Linux can be very useful. But the bottom line here is really to A, make sure it's a lean base image, B, that you're able to maintain that over time, and then C, even ideally, have the ability to automate rebuilds as you update these base images over time. Now, what are the benefits here? One, by using a lean base image in particular, that means that you have fewer components that should require updating over time, which means you have a much smaller attack surface that needs to be managed for over time. Second of all, it also then means that you're not having to trigger as many rebuilds of applications and hopefully minimizes the amount of disruption or developer time that's necessary to rework applications when you update those base images. The other thing that's very interesting with using a lean base image is that it then also requires development teams to be very detailed in their build manifests, in terms of the build manifests, that is, in order to ensure that they're being very explicit in what they actually need to add to the environment that may need to be maintained over time. Especially if you're making use of software composition analysis, this sort of thing becomes very useful in terms of understanding where vulnerabilities may be introduced within your pipeline and understanding who has responsibility and accountability for ensuring any sort of vulnerabilities that do crop up inside of these container builds are in fact remediated in a timely fashion. And again, this kind of gets back to that baseline concept of baking security in, which we've talked about frequently over the last 15 to 20 years. But with containers, it really is true. Any tooling that you need to have inside the container has to be integrated at build time within your CI/CD pipeline. If you don't do that, then everything is going to have to be loaded, either side-loaded in a sidecar type fashion or integrated in a proxy type manner inline, such as with a WAF or similar type tools. So again, especially for base images security, we want to make sure we get that stuff all there from the outset so that development teams can work with it right away rather than having to have it loaded in after the fact. Okay, so we've secured the code, we secured the application or tested the application to ensure it's built properly, and we have a base image. What next? Well, up next is container configuration. One of the very interesting aspects of container security is the fact that we're not just focused on securing the containers themselves. In fact, we do have to go to a little bit greater length. Well, let me rephrase it. Not just securing the operating system itself. We also have to talk about securing the container itself as well. And so there's a lot of potential complicating factors that come into here. Luckily, CIS does maintain a benchmark for Docker, and they work very hard to keep that as current as possible as Docker containers evolve. Docker also themselves have a reference architecture with security best practices that you can leverage. A lot of these best practices often come down to a handful of guidance around how to lock it down. First and foremost, use SE Linux or comparable methods in order to lock the operating system down itself. That helps you, again, minimize the attack surface that may be exposed within the container itself. Next, you want to severely restrict socket access. In fact, no access is best. You really don't want to be introducing changes at all directly into the container. You want to just be pushing the container out into your operational environment and letting it run. The other option is to treat it as a traditional VM. And again, these are not traditional VMs. And then the last one here is enabling content trust as well. Also a very common recommendation. And if you click on the links, you can get more details on that overall. Because we're not dealing with VMs, we also do not want to enable SSH access. And this is a very important point because oftentimes teams who think in a very traditional VM-like manner will think, oh, I need to hop onto the container and troubleshoot something, or, oh, I just want to go patch in place and just update the container in place. And that's really not what you want to do with containers. You really want to, in fact, make use of what's known as a green-blue deployment type model, where you build your new container images, you do all the full testing on them, and then you deploy the new container images alongside the old ones. You ramp the new images up as you transfer loads and ramp the old images down. And that then provides hopefully as seamless transition as possible, and it gets us away from patch in place. You still do have to maintain the application and the base image over time, right? There's just no way of getting around that. But the last thing we want is people going in and tampering with images and running containers in production. And there's some good monitoring reasons for this in particular. And again, just kind of that reminder, a solidly secure container starts with a solidly secure base image. It's really important that we start from a really good known secure base. And then we can monitor for changes against that. And we'll get into that in a couple of slides here. Okay, so we've secured the code. We've done AppSec testing. We've got a good base image. We've reviewed and ensured decent container configuration. What comes next? Well, as you might expect, container management, or Kubernetes, which is the most common container management framework these days, deployed pretty much everywhere. Again, CIS benchmark CIS does maintain a benchmark for Kubernetes. They're doing their best to keep up with versioning. Kubernetes, if anybody who's worked with it knows, it does seem to change on a very regular and frequent basis. There is also a O'Reilly book out there on Kubernetes security, which has been recommended by several people as well. And you can find numerous references out in the interwebs, if you will, on Kubernetes security too. One of the biggest changes that has occurred in the last couple of years is the move to use of daemon sets for tools in your nodes. Now, let's stop and talk briefly for those not familiar with terminology around Kubernetes. You have nodes and you have pods. Pods are essentially the running containers themselves, and nodes or worker nodes are the base systems that are in fact managing and running the pods. So if you think about the traditional VM type model, you have the VM server itself, that would be your worker node, and then the VMs are the pods or running container images out there. That's about as far as we should take that analogy, because again, things get very different very quickly. So some additional things to look for here with container management in Kubernetes. First and foremost, we really want to lock it down, limit access as much as possible, leveraging known good configs and tools. And really what we're talking about here is, in fact, driving people to only engage with the K8s framework, which K8s is the common abbreviation for Kubernetes. That's because the K is followed by 8 letters and then the letter S. So Kubernetes or K8s, oftentimes you really just want to be interacting with that via your CI/CD pipeline. There really should never be human level access in there at all. It should be all largely programmatic. And so we should be able to lock it down fairly strictly and limit access to only automated interfaces, programmatic interfaces. Second of all, we have to work very diligently to keep the nodes current as well, because they do in fact have base images and they do need to be updated. If anybody works within EKS, you may notice that it seems like every other week, AWS is announcing support for the latest version of Kubernetes. I think in the last month or two, I've seen everything from 1.14 all the way through 1.18 as versions of Kubernetes having been released. And every single one of those requires updating your entire framework environment, including updating the worker nodes. So there is a degree of maintenance that has to go into all of these efforts. And the good news, however, is because we're typically working with clusters, so oftentimes you have a cluster of nodes that are maintaining all of your pods, that does give you some degree of resilience so that you can upgrade your worker nodes underneath without interrupting your production environment at all. The last point here is again, just kind of reiterating things that, there should be no root, there should be no privileged mode And again, use your frameworks instead of direct access. And that is where the daemon sets notion comes into play as well. It used to be you would directly load security tools, for example, onto the nodes themselves or even into container builds to run within pods. And now you can use daemon sets to load tools in a more secure manner, similar to kind of your jailing or sudo root type stuff as well. So it gives you some better options overall and some better flexibility and resilience. Okay, so we've talked about secure coding, we've talked about application security, we've talked about the base image, we've talked about container security, or the container config itself, and now we've talked about container management or Kubernetes. What could possibly be left? Well, let's talk about a thing called drift, if you will. What is drift? Drift is when a container is deployed to production and then changes in production versus how it was initially built. As you consider what a CI/CD pipeline looks like as part of your deployments, you will always have some sort of container registry within your pipeline where you check in your built container images. From that registry, you will then use your Kubernetes framework interfaces to deploy that container to production. A very bad practice is one that allows development teams and operational teams to directly, as I mentioned before, don't allow SSH. And one of the reasons for that is that if you allow SSH, it provides the temptation to go directly into your containers within your production environment and institute changes. However, in so doing, it violates the principle of immutability. And you say, well, why immutability? Where do we get this all of a sudden? Well, the idea with containers is that once you've deployed the container to production, it should not change. And so from a security monitoring perspective, if you detect change or drift within your container, that should be a red flag that indicates, something's wrong here. Something might have, maybe an attacker has been successful or maybe an attack is ongoing. We want to monitor for those types of changes. So again, it's really important then to require your ops and dev teams to only go through approved channels to introduce containers and deploy containers into production environments. Similarly, we also need to ensure that our development teams are not post-loading components at container start time rather than integrating them directly into the build. This is another similar practice that I've seen in the past, which introduced drift because the container itself will not have all of the important or necessary components in the build itself as it's checked into the registry. So when it starts running in production, the first thing it does as part of its startup processes is it downloads and installs a bunch of additional components. Well, there goes your ability to monitor for drift, and there goes the principle of immutability, because now you don't really know what to model after and what looks like a good container versus a bad container. And similarly, that also effectively bypasses some of your security testing that you will have done in the CI/CD pipeline. For example, if you're using software composition analysis and scanning your image in the pipeline, but the image itself, the container, is not loading all of the components necessary for the application at runtime, you're going to miss things. And I have seen cases where development teams have downloaded library packs directly from repos online, such as NPM, and installed them as part of the container startup process, or Java modules, Python, etc. I mean, take your pick. Regardless, the net result here is that you end up having containers that significantly and materially deviate from the images that are checked into your container registry, and it really blows your ability to monitor for changes to that environment. And then again, revisiting this concept of blue-green deployment, again, it's very important for your tool chain, from a tool chain perspective, you really ideally want to deploy new images alongside old images. And this is done for resilience and redundancy purposes, where if you deploy a new image and something seems to fail right away, it allows you to quickly fail back to your previous known good state. This is also, by the way, why we register all of these images within our container registry too, instead of overwriting things along the way. In that blue-green, again, we deploy the new, start transferring workloads to it, and then start taking down the green, the previous versions. And this essentially allows you to, I might have the blue and the green backwards, but you get understand the notion here, right? Which is that we want to be careful and side-by-side do deployments overall, rather than going in and doing patch in place. And again, all of this is to support this notion of drift detection and enforcing immutability within your environments, which becomes a very powerful way to detect any sort of attacks going on and potentially succeeding against your target environment there. So we've covered pretty much everything across the board here, but there is one more area. Even if you do 1 through 6 well, you still are going to have exposure. As you might normally expect, the very moment that you spin up a container and open a firewall or security group rule to the world, you're going to start taking traffic, right? And as soon as you start taking that traffic, you now open the door to being attacked. So how do we deal with this? Runtime protection is the most common approach. Some of the common practices that are used from a runtime protection perspective include things like rogue process detection. That can sometimes be done via a daemon set loaded into the worker node itself rather than into the container or within the pod. Rogue process detection would basically baseline your running image, and then if it sees new processes spin up that don't match with what it's previously baselined against, it will do an alert or even potentially automatically kill that. Again, drift detection, also a very easy and useful method for determining that something may be going wrong or going bad within your environment. And then the more advanced method that we have seen for the last 5 years or so from a lot of the top vendors is behavior modeling, both of the application itself as well as network traffic. And this can be done either in a sidecar design, monitoring through API calls, or even as a full inline proxy for your running containers as well. And this gets into this notion here of common models. So again, kind of in the node, whether it's a traditional deployment into the worker node itself or in a daemon set, sidecar, which monitors, or now even also the ability to make use of embedded agents. So for example, within AWS ECS Fargate, you don't have control of, it's a fully managed Kubernetes environment. So you don't have control of the underlying substrate at all. All you control is what you bake into the container itself before you throw it out into the world to run. And so that's where embedded agents oftentimes come into play, where you have no means to deploy a sidecar, for example, because you don't know where the sidecar would be deployed relative to your container. And similarly, you don't control the underlying nodes as well. And so an embedded agent can potentially be used. So that kind of summarizes, if you will, to me, 7 layers of container insecurity. So just to recap this a little bit, again, what did we talk about? First and foremost, we have to secure the code itself. We have to work with our development teams. We must be involved from a design and architecture perspective. We need to make sure everybody understands kind of how they're approaching things and set standards and standard practices such as CI/CD pipelines and deployment models and practices such as blue-green to make sure that everybody understands what their responsibilities are. Anybody who is deploying within a cloud computing environment these days, which is pretty much all of you, right, there is a shared responsibility model. And so similarly, we also have to impart and achieve understanding with our development teams that they also have a part to play in this shared responsibility model. And so it's imperative that we kind of keep that going forward. Second of all, we have to work on our AppSec tooling. Try to integrate that within pipelines as much as humanly possible. Yes, I know, SAST, DAST, they're not going to be fast enough to keep up with desired build velocity. And so the reality is we're probably going to end up having to fork some of that scanning information out. The key is, what do you do with that data once you have it? How do you feed it back to development teams? And again, it's imperative that we work with our development teams to understand what their ways of working are. How do they do their work? And how can we best provide that feedback? Maybe it is generating JIRA tickets. Maybe it is getting involved in stand-ups or retros. Maybe it is just outright developer education, or maybe it's even going in and directly enabling remediation tools such as Dependabot that can actually trigger updates to libraries directly within the repository that create branches and merges, or either automated or the opportunity for merges to pull in these changes. So there's a lot of things that we can do with that. Number 3, we talked about the base image. So even though a container is not a VM, we do still have operating system components in play, and therefore we do have to work to create secure, lean base images, preferably purpose-built images for containerized environments, and then we must maintain them over time and provide the supporting infrastructure as code environment that will allow us to keep them current. We talked about container configuration, limiting access, shutting down what might be considered appropriate in traditional environments such as SSH or socket access, enabling SE Linux and things like that. We talked about Kubernetes configuration management as well. Similar deal where we want to lock down any form of privileged access, really limit access in general to being programmatic coming out of the pipeline, and not enable access beyond that, to the degree that we don't really want anybody to be live in production as a human whenever possible. We then talked about drift and immutability. The principle of immutability, again, being that we don't want our containers to change at all once they're deployed to production. So everything needs to be baked in prior to check-in to the container registry. And then lastly, our last line of defense here, runtime protection. Completeness of security architecture is absolutely critical. In order to really have reasonable coverage of container security and even serverless security and cloud security, we have to hit on all 7 of these layers. We talk about it as defense in depth if you want to, but the key is that there are no magic bullets. There are no single comprehensive solutions. There are solutions that cover a lot of these, but you'll notice the shift and blend over time that we really started from secure coding and AppSec, got into infrastructure, and then got into security monitoring. So in many ways, we talked about at least 3 entirely different and largely non-overlapping domains of practice overall. And discipline is so important, right? Not only security team discipline, but also operations team discipline, and very much so development team. We cannot have teams going rogue, just going out and launching stuff into the cloud sphere, the universe as we know it, without having proper forethought and practice and protection in place. Now, having gone through all of that, but wait, there's more. So on top of all of these things, there are some meta topics that we also really need to talk about within our organizations. First and foremost, you really do need to have a reasonable degree of DevOps maturity to be able to handle any of this stuff really well. And this leads to some key questions here. Do you have skilled resources? Do you have the right personnel? To quote Jim Collins in Good to Great, do you have the right people on the bus? It's really difficult to find strong technical people. I think it's very important that you go out and find savvy, hardworking people who are willing to invest in themselves and the company and learn and develop skills, and then work to retain that talent. Ultimately, that oftentimes will have significant benefits and pay dividends. And maybe they're not even coming from security backgrounds. I've had a lot of success working with people coming from both an ops background and a dev background in order to then train them up on the security side of things, because they already understand the fundamental technology issues and how to make use of things. The second question here, how is your CI/CD toolchain? Do you have a reasonably defined and standardized toolchain in place? How automated is it? How much opportunity is there for building hooks into it? Are you able to integrate your security tools? And then that leads into that last question, which is, how is your security tooling? Do you have enough tools? Do you need more tools? There are potentially a lot of free and open source software packages out there that you can leverage. Tons of things you can do to get into it, and we'll talk about that in a moment. And then of course there are lots of commercial solutions, many of which are extremely expensive, but oftentimes also do a very good job. Aside from DevOps maturity, we also need to talk about organizational culture and political support, because fundamentally, change is hard, as is keeping up with the bleeding edge. I have worked in organizations where they wanted to very rapidly iterate and evolve, not just from traditional EC2 or operating system-based deployments to containers and microservices, but also straight to the bleeding edge of serverless, and having architectures where they're directly exposing all of their microservices directly to the world for as APIs to directly consume. Boy, that's a huge jump as a security professional. In a world where I'm used to limiting ingress points within my environment and having some reasonable degree of control over how stuff comes in, and being able to keep control of things a bit, at least to limit my resource spend across the organization, now to be asked to suddenly scale that out at cloud scale and keep up with some of these development teams is very difficult. And so this oftentimes leads to very difficult conversations with technical leadership teams to say, listen, we cannot move as quickly as development teams necessarily want to go. And that's a good thing. right? We have to be able to maintain operational cadence in order to support our environments. We have to be able to maintain some degree of security management over our environments. And the reality is, sad but true, is that a lot of these security tools simply are not keeping up over time. Microservices, are, I say now, a newish paradigm. A year ago I would have said a new paradigm, but it's really newish now, and we're getting almost to the point where it's a fairly well-established deployment model as well. But we really need to catch up and have time to mature with this as well. Also, who's paying for the initial transformation, and how do we make sure that security is a vital consideration overall for this? And then the third area for for discussion really comes around commercial security tool maturity. The bottom line is, despite startups in the space, most security tools, especially mature security tools, are 5+ years behind the curve on a lot of things. And it can be very difficult working with a lot of your vendors, especially in things like the AppSec testing space, trying to figure out how to take a very traditional SAST approach and integrate it into a CI/CD pipeline where you want to build the complete in a matter of minutes. And your SAST scan can potentially take hours. That simply doesn't work. And so we are going to have to continue collectively working with our commercial tool vendors to find ways to still achieve the same or ideally better results while also fitting it within the constraints that are set on us from our development teams and DevOps teams as well. We still continue to struggle with finding tools that are truly cloud native as well. Oftentimes you will find deployment models that just end up being very expensive purely on the infrastructure side because the model that they're using does not well align to a true cloud native model. And that bottom line there, talking with vendors can be very painful and frustrating at times. Find a friend to commiserate with, because you have to have these very tough conversations with them. You need to start pushing them towards being much more cloud native in their overall approach, and having the flexibility and to pivot and adapt over time. And again, to me, the biggest scary thing is microservices quickly evolving on the bleeding edge, where a year or two ago we were just starting to talk about container security. Well, now all of a sudden everything's about ready to jump that and go straight to serverless, where there are no containers to secure. It is just the application as APIs overall. So how do we adapt to that, and how do our vendors keep up with that as well? It can be a very challenging and difficult conversation. Inevitably, at this point, you've probably overloaded. A lot of information has been flowing out here, and you might be thinking, well, Ben, that's all good and fine. I'm not going to be able to go out and change my org culture necessarily right away, because again, change is hard, and having these difficult conversations isn't always what you want to do. Where do I start? Where do I get the best bang for my buck? So let me tell you, I think that these 5 things really provide a good starting point. First and foremost, I think it's imperative to start with a well-maintained lean OS base image. Why is that? Well, simply put, as mentioned earlier, it reduces your attack surface significantly. It makes it easier to maintain and support it over time. But it also, again, has to be a well-maintained image. It can't be some random distro you just found out on the web that may or may not have any sort of long-term support. You really do want to make sure you find a base image that has been purpose-built for containers and does, in fact, have a good history of supportability over time. Even better if it's owned by your cloud vendor. Number 2, make use of the FOSS security tools that are out there. It could be Claire and Clara combined. It could be Anchor Engine. It could be Cloud Custodian. It could be Cloud Splane. There are literally dozens of FOSS tools that you can leverage to help monitor and secure your environments. Will it do everything? No. But it will help you at least get over the threshold and help you develop data and metrics that you can then use to justify further security investment going forward to help you secure not only containers, but your cloud environment too. The name of the game is gain some degree of visibility, gather that information, gather that data, and then leverage that to help chart a path towards improved maturity. Also, don't overlook things like the CIS benchmarks and supporting tools. Again, they're fighting very hard to try to keep up with the fast pace of change, doing a reasonably good job, and thankfully, for the most part, things do not change dramatically over time, in short times, typically. So do what you can to leverage things like CIS benchmarks. You'll find that that provides a very straightforward means for kind of monitoring progress. Number 3 here is make sure that you get a source to prod or source to stage, at least CI/CD tooled up and quickly. Having a consistent standardized pipeline through which everything else flows and through which all of your tools integrate will pay dividends in the long run. Again, this also means having those difficult conversations with your commercial vendors around how do I actually get the value and benefit out of there. Now, there are tools out there that do allow you to integrate with these pipelines in a more automated fashion, as well as collect and aggregate some of the data out there. And so if you look up tools like that, whether that be things like Zero North or a tool from Denim Group as well, there are a few tools, and I think an emerging number of tools from a security management or application security management perspective that will benefit you in the long term in terms of helping you with your integration within CI/CD as well. But standardization is the name of the game, and setting clear expectations for people is very critical. Number 4, again, optimize monitoring as much as possible. And again, you can leverage commercial tools as well as free and open source tools like Falco. Again, you need to generate that data, start finding ways to monitor, set a baseline and monitor that baseline. And again, simple things like drift detection can be highly beneficial in the long term. And then the last point here, lock things down hard for true cloud nativeness. We want to get human interaction, human users out of production environments completely. Everything should be accessed through a pipeline, which then clears your gating points and achieves all of the necessary checks. And again, this also contributes then to actively shifting thinking to more of a cloud native mindset. So, following up on the question that I asked you at the very beginning, how's your journey so far? How have you progressed? How complete is your vision and your set of practices? I hope that this presentation has provided some insights for you into areas where, hey, I hadn't thought about that, or, oh, I probably can improve there, or, oh, look, there's an opportunity for a quick win. I'm always available. Apologies, the link here is a little bit my last name there at secureconsulting.net, or hit me on LinkedIn or Twitter. Certainly welcome your conversations, and I again hope that you enjoy this conversation. Thank you for your attendance today, and I look forward to.
Well, hello all. This is Lara from ISC2, and we're here with Ben live. Ben, you there?
I think so.
There you go. To answer your questions.
Hopefully you can hear me.
All right. Yes, can hear you, and you sound great. So thank you so much for that thorough presentation. And just in case anyone missed anything, there is a PDF in the attachments section so they can get a copy of your presentation, Ben. And if they wanted to listen to it again, it'll be available in a half hour after we close this presentation. So let's dive into a few of the questions we got from the group here today. And let's see where that takes us. Okay, Ben? All right, so what suggestions do you have for securing access from containers to legacy non-container systems, like for databases, for example, specifically traditional mechanisms like network firewalls, not as effective? You have any thoughts on that?
It's hard to give that one's a hard one to kind of straight up answer because it gets into a lot of the minutiae of a given architecture. One of the challenges typically is, within container environments, we're not necessarily working in the same manner as we would in a more of a legacy cloud sense with VPCs and VPC peering and security group configs and things like that. So, for the most part, I think a lot of the integrations these days will typically occur over some sort of secured channel, like an HTTPS type call between services or from APIs to front-end apps, things like that. But it's a much more involved technical conversation. Unfortunately, I think to get into kind of all of the specifics, because there's literally probably a dozen different ways you can skin that cat if you would.
Okay, so let's see what else we have here. Do you have any recommendations on what to use or how to monitor for changes in deployed containers?
Yeah, I was. While the talk was running, I was trying to look and see if there was anything in the open source community. I haven't found anything yet. Oftentimes I've done this with commercial tools. It doesn't even have to necessarily be an elaborate, more expensive container security tool per se. For example, I know that Qualys will provide monitoring capabilities. Essentially what you're doing is you're just monitoring the image itself as it's been checked into your container registry and comparing that against the running container within wherever you're hosting your containers, whether that be in EKS or GKE or AKS or even your own Docker cluster somewhere. So that's the key, is finding some tools to leverage off of that. Sorry, I don't have a much better answer than that at this point.
No, that's okay. I think that's good. That's good. What are your thoughts, Ben, on your thoughts or recommendations around securing APIs?
Yeah, API security is a whole talk or 10 in and of itself, right? So, again, that gets into a lot of the architectural nuances of how you build your APIs. Do you have one entry point for your APIs? Do you end up having multiple entry points for your APIs? Do you use some sort of realming structure to break it up so that you're only exposing certain types of, or certain subsets of your APIs to certain populations of consumers? For example, you may break it up between, public-facing APIs within one realming, internal services set up another way, and then you can talk about how you can kind of lock down that access, whether that's through providing separate front ends for those APIs to consume, or whether that's some sort of internal type control. Even something as simple as dropping Nginx or API gateway in front of it, and then using API gateway just added mutual TLS, for example, in the last couple of weeks that you can use to authenticate into between services. So again, there's a lot of different ways you can kind of tackle that, really depending on what works best for your organization and what is most sound for how you want to approach your app architecture.
Okay, moving on to one of the ones here too. What's the best way to deal with some false positives and scanning of containers?
Yeah, false positives obviously continue to be a challenge. Although, to be honest, I'm far more concerned about not catching things than reporting on things that are potentially false positives. There's a number of ways to minimize the false positives, and I think that's really where you want to take that conversation. That's where having things like a lean operating system as the base for your container images comes in to be very beneficial, because it allows you then to, limit the amount of targets that you're scanning within your environment, which will reduce the potential for false positives. I'm also a fan of tools like software composition analysis that work from a known good set of potential known vulnerabilities in libraries, for example. And so you don't tend to have any real false positives with that type of approach, because it's going to identify a library version and go, oh, we know for a fact that there's a vulnerability here, and then you can remediate and follow up accordingly.
Okay, great. So you talked about the difference between securing the container versus the OS. Can you call out a few specific controls that are missed at the container level?
Again, it's going to be difficult. So
okay,
there's a lot of things, right? And I think if you go through, I know somebody mentioned in the comments that the Docker reference architecture link might be bad, but between that and the CIS benchmark for Docker specifically, that can be very helpful. There's a lot of stuff. Oftentimes it boils down to things like, again, no SSH access in there. Oftentimes you want to enable SE Linux mode within your container base image that's literally within the running container image itself to lock things down. Lockdown, if you're using Docker, locking down the Docker socket as well to make sure you don't have overly permissive access to that. There's a lot to do between both the worker node and the pods themselves, and so you kind of have to blend the two and make sure that you're, again, limiting that attack surface as much as possible and keeping things as nice and tight as you can.
Okay. So you a little bit broader approach here. You mentioned working with our dev teams, right? Would you say, this is a question early on, but would you say it's equally important for developers to understand how to code securely? I'm assuming your answer would be yes, but I'm not going to put words in your mouth. But how do you foster that environment? Do you have a point of view or perspective on that?
Yeah, I mean, application security and secure coding, is one of those, major domains that we're kind of touching on in this talk. And there's no easy path, right? So you have to essentially do some degree of education, training, and awareness with your development teams. But that also requires them to buy into what you're telling them, right? And so it's really important to have well-qualified AppSec people who have some understanding of development, or if not an outright development background. That tends to lend credibility to having conversations with your development teams to go, okay, I see what you're doing. You're trying to write X type of component, or you're trying to create an API, you're trying to create a front end, and I see that you're using this language set. And when I use that language set, these are some of the issues I ran into. And being able to kind of have that conversation and walk along that path oftentimes tends to be very beneficial and tends to work better overall, rather than coming in kind of cold. It is also important, as I mentioned in the talk, to really get multiple touch points throughout the entire development lifecycle. And you say something like development lifecycle that sometimes might foster concerns about, oh, now we're talking about waterfall or something. But to be quite honest, even in an agile world where you're doing a drop a day, you're still following a life cycle of some sort for all of your coding. Peer review tends to be very useful in making sure that teams are trained up on peer review. Test-driven development, TDD, is also extremely useful. TDD says that you define the test first before you write any code, and the test should fail immediately. If the test doesn't fail, then you don't need to write functionality. So then the developer has something that they work against, and that automatically integrates into your QA, UAT test suite as well, so that when it gets to the UAT stage of things, or the testing stage of things, that test is already written. You already know when it will succeed and when it will fail, and that becomes part of your overall run book from a QA, and preferably an automated QA perspective too. But yeah, this is a huge topic area, and a lot of it is about that human element of working with people and establishing credibility, helping them understand what the challenges are, and helping to nudge them towards approaches that will help with incremental improvements rather than trying to go for massive big bang type improvements as well.
Okay. Thank you. So Ben, do you have any recommendations about securing secrets within containers?
Yes, please do so.
Exactly.
This is a huge challenge. I think one of the things that you want to do on a for sure is be actively scanning your source code repositories, your repos, whether you're using tools in Git or using tools in GitLab. There are, in fact, native tools as well as third-party tools to scan for embedded secrets and credentials. That's a really good starting point overall. Similarly, wherever possible, you want to get away from overusing secrets. I've seen this where AWS access keys, for example, are used extensively to secure communication between components. The problem is that that's extremely hard to manage at scale. And if you are rotating those keys, or at least trying to rotate those keys, that can suddenly become extremely difficult. And that's where you typically want to shift more to role-based access, leveraging native IAM capabilities and things like that. And then, beyond that, when you do actually have a need for actual secrets management, whether that be for encryption or for other purposes, there's a number of things you can do. A lot of organizations, historically have used Hashi Vault for that. You can use Secrets Manager and KMS within AWS. Similarly, Azure has, I think it's called Key Store, so on and so forth. So, the specifics tend to really get into what works best for the environment where you're developing and deploying your applications. But yeah, more importantly than anything is to have a cognizant, explicit approach to secrets management and not allow for the embedding of those secrets within code bases wherever possible.
Okay, so here's an interesting one. Will containers fall out of favor in the next 3 years and be replaced by application and direct APIs, requiring yet maybe another security approach, you think?
Yeah, sadly, I think we're starting to see that. In many ways, I almost felt regretful giving a talk on container security, especially late in 2020, as we really are starting to see a very rapid acceleration to move towards serverless. This was predicted by some folks over the last few years, in particular, that container security and containers would just be a short stopping point. What I would say, however, as a word of caution, and anybody who's dealing with this rapid evolution from containers all the way straight to serverless and step functions and things like that, is you've got to have a lot of organizational maturity, a lot of DevOps maturity, to be able to manage securing and just operationally supporting serverless environments. And I think we're in many cases seeing too rapid of a move to serverless and skipping through containers, where we really should be taking a pause, and solidifying kind of how we deal with microservices at the container level before we go adding a tremendous amount of additional complexity by going to serverless. We're suddenly now, instead of having sets of capabilities in one container, now we're starting to deploy each individual capability as its own individual API, such as through Lambdas or things like that. So, I think sadly, again, we're probably going to see that jump in the next few years, but I would also encourage folks to actively push back on development or engineering teams to slow them down and help them understand that what they're asking for, while maybe technically feasible, isn't necessarily the smartest move to do today, right? Give us some time. I mean, our security tools aren't even keeping up with container security as it is, and the thought that we might have any security tooling, at least from a commercial perspective, to cover serverless as well, very thin at this point, and it's probably going to be a couple of years before we see anything truly reasonable in that regard.
Okay. All right. Now switching gears a little bit, but we're going to shift to like upper management. In your experience, what's the best strategy to get that buy-in, from upper management to implement or improve container security, knowing it may slow down the release cycle?
Well, okay. So first and foremost, let's talk about the last part of that, which I think is critical, right? So security is almost always seen as a blocker of some sort. And so I think it's incumbent upon us as security professionals to minimize that negative impact as much as possible. And a very tangible example of that is static and dynamic AppSec testing tools, for example. You simply cannot, for the most part, directly integrate those into your CI/CD inline and expect development teams to be even remotely happy about it, because they tend to run too slowly. Static AppSec testing especially is just extremely slow, and especially on larger applications. So how do you deal with that? Well, there's a number of things you can do. You can fork out those scans and then bring them back in, whether that's through directly or through platforms like a Zero North or a ThreadFix, in order to integrate and represent some of those findings. Or you start working with your development teams to get some of that scanning even further to the left, where you can do those scans on smaller sections of code, so that the scan times tend to be much faster and much lower impact. So that, I think, is really the starting point for part of that challenge, is how do you get more efficient, more effective, and really honestly more lean as a security team in how you apply some of those practices. Other things you need to do is, you can't just sit back and wait for stuff to come to you. You have to get out there. You have to start working directly with development teams. You need to be in those ideation meetings, storyboard meetings, as they're creating tickets. You need to start setting requirements and expectations for performance. And that, of course, then requires having support from upper management to actually follow through and enforce requirements. It's one thing to say, oh yeah, security is important to us. It's another thing to say, okay, we're writing security requirements directly into the non-functional requirements for a given application, and we will ensure that those get implemented. They don't just sit in the backlog forever and maybe get pecked off once in a while if it's convenient for somebody. You actually have to commit to that. And that also then follows through into the rest of the ecosystem around containers and microservices, in terms of making sure that, hey, we're not just going to let you go grab some random image off of the internet and be able to start deploying against that. We need to be working from known good starting points. Here's a good, tightly baked, lean OS for you to use for your container build. And you want to put things into that, that's great. Put it all in your manifest. And when you build it out, I want to make sure that I see everything in there, right? That getting to that state where immutability is the status quo ends up being extremely important, because it forces discipline earlier in the process, or farther to the left, as they say, right? So that developers don't try to sneak things in after the fact as well. So it's an ongoing process. How it works within your organization will really depend on what your org culture is, what your values are overall as an organization, and how you can go about instituting changes. Sometimes you have to do it from a grassroots perspective. Find the small changes you can do here and there. Other places you can find much higher level support and start initiating larger scale projects where you literally are doing all 7 layers at the same time, doing active education of developers, actively deploying tools and optimizing your tools in the pipeline, actively working on securing the underlying infrastructure, getting the monitoring in place, et cetera, right? But again, it comes down to how deep are your pockets, how supportive is your upper management, and how well resourced are you even as a security program to be able to support all of these different attributes of the entire ecosystem.
Okay. Ben, so say we want to learn more about this. Do you have any recommendations on a good comprehensive source of container security knowledge for learning, either like books, exams, training courses, any direction to point us in?
No single direction.
Okay.
As we should expect from the security industry, for every domain, there's subdomains and myriad resources. Obviously, ISC2 does provide some training materials that we can point to. OWASP often has good references for security. Definitely go and check out the CIS benchmarks. Go read the documentation that's provided by Docker. They've invested a lot in security over the years, especially 3 to 5 years ago. They put a lot of emphasis on that, and they've developed a lot of good reference architectures as well. Find tools and find tool communities that you can interact with. And then, social media can oftentimes be a good place, especially Twitter, to find communities or sub-communities of people to communicate with, as well as, even looking for some of the vendors and some of the specific talks. Go look at KubeCon, for example, and find the small number of security people who are giving talks within KubeCon overall, and kind of leverage off of their experience and follow where they came from and the path that they're on. That's about the best as I can give you at this point.
No, that's great. Thank you for that. Any closing thoughts? Because we're going to wrap up the Q&A at this point in time. Ben, any closing thoughts to share? Yeah,
I will leave everybody with this notion. As you unpack every single one of the 7 layers that I described, there's a set of talks within each one of those, and no organization reasonably is going to be able to go tackle every single one of those simultaneously all at once. You'll go bankrupt, and more importantly, you'll go crazy and probably become depressed in the process. So for your organization, it's really vital, especially from a self-preservation perspective, to understand your business, understand your organization, understand the teams that you're working with, and find those opportunities to get some successes and celebrate every single success that you are able to achieve, no matter how small or how big. Because ultimately, it's all about building momentum, building credibility, and being able to demonstrate that, hey, look, we were able to be successful here and achieve something without having a huge negative impact on the lives of others within the organization, and yet we were able to appreciably reduce risk in this area. Being able to say that and feel good about that is really critical overall, as is having reasonable expectations for how much you will be able to do in a short period of time.
Okay. Well, thank you, Ben. We appreciate your insights and your time. And thank you all as well, everyone who joined us today in this session. As a reminder, this session will be made available on demand in about a half hour following the close of this session. Everyone that's on, please rate the session. We do want to hear your feedback, as this is our first virtual Congress. We want to hear from you what's working, what's not, and what you got out of the session. Also, please visit the attachments section. There you'll find, as I mentioned earlier, a PDF of the presentation and a free copy of our award-winning magazine. So we thank you all again and enjoy Security Congress.
Thank you for attending ISC2 Security Congress 2020. Please know that at the end of this session, you'll be able to rate it, and we look forward to hearing your feedback. ISC2 members, CPEs for attending Security Congress will be applied to your account 30 days after the event. Thank you for attending this session.